All right, but I'm going to go over it just so we have a record of it. And refresh your memory. Like here's where I want to go here. All right, so here we have a micrometer. And we'll note all the little nuances of the micrometer and the things that we should be using correctly. There we go. All right. Thankfully, so I got words on here. Sometimes I don't worry so much about the nomenclature. All right, but on the anvils, they do have carbide tip bases. They're very hard. They're there to resist wear. You have to be careful not to scratch parts with them because it's harder than usually than the parts that you're dealing with. You do have the frame, and notice this says a heat insulated handle because as these things heat and cool, they actually can spread open and close a little bit. So this particular one is a 0 to 1 micrometer. And when it is all the way closed, these two tips touching each other, this should read 0. That's one way you can check the accuracy. The other way is check it on this end and you open it all the way up and use what's called a standard. It's an exact 1-inch block that has been calibrated and certified 1 inch. And you put it in here and then this should read 1 inch at the other end. All right, so you always want to check that. We have on this end an important part. It is the ratchet. The thing about a ratchet is it is there to tell you when to stop turning. This one doesn't click. Too bad. It is, all right.
Yes.
It works. Got me a click in. All right. So it's there to tell you when you have done it enough. Because if you don't and you're just twisting like this, you actually force this together and spreads it out. So now, if I take this and force it, and then I do this, what do you think is going to happen? Well, it's already been over-tightened and forced, so what's this going to do? Nothing. Okay, so don't tighten it here too much and then do that, because that's just ridiculous. All right, so what you're supposed to do is use this, bring it up gently until it clicks. And what that does is it gives you repeatability. You're doing the exact same proper tightness time after time after time. And then when you get really good at it, you can use without it, but it's designed to be used, so use it. So, but you have to be careful. I'll get into some other stuff. So use the ratchet appropriately. You tighten with the ratchet, not this, and then do that, because it's already tight. So that's going to always click. We have, what else are we going to go to here? We have the thimble. Now, don't look at that as metric. Mess it up. The thimble, which is this part right here that goes round and round. This part here that goes round and round, part that goes round and round, represents 1/1000th of an inch. You have a question? Yes.
Any time in this class, are we using digital ones, or is that too easy?
I don't want to say it's too easy. You will not be using digital. And the reason why you will not be using digital is because at some point you're going to go have to take a test with the mechanic examiner. And when you get to the mechanic examiner, we want you to be using the most difficult equipment possible so that nothing will shock you. You will get something like this and you go, oh, well, I only know how to use a digital. And guess how well that's going to go on your test that day?
Not very well.
As a mechanic examiner, I would probably have to say something like, well, that's a shame. Thank you for paying your fee. Now go home and study up how to use this and come back and retest when you figured it out. So as an A&P, you got to be able to use both. So, all right. It's always somebody looking for the easy way out. All right, so it represents 1/1000th of an inch. All right, so 1/1000th of an inch is how much? 0.001. All right, so this represents 0.001 of an inch. It goes from 0 all the way around to 25. So a little thimble starts over here at 0. So if this were a micrometer and we're all the way closed, see this line right here? Okay, all the way closed. I'm going to read off that line. All the way closed, I would see 0, 0. Now I like to say that micrometers have a personality. Every single micrometer has a personality. And that's one of the reasons why you're not turning in your micrometers at night. Because I found that every time you turn them in and you get a new set, it has a different personality. And you have to relearn a micrometer. So a lot of times when I'm working with you, I pick up you'll see me messing with it a little bit, I'm figuring out its personality. And by that, I mean that sometimes when you look at a micrometer, they're perfect. And you will see half of this little black line when it's on 0, and you're like, all right. Sometimes you'll see the whole black line and a little bit of space when it's on 0, and sometimes you won't see that line at all. But it's still 0. Got it? All right, so that's what I mean by personality. They can be just a little off on there. But in a perfect world, I would see half of that line going this way, lined up on 0 when it's totally closed, right? Now this has 40 threads per inch, which means it will go around 40 times in 1 inch, and that just happens to work out that it'll go around a perfect amount of times to give us the reading. So as I go around, the thimble represents 1/1000th of an inch. So I come to right here, and I have one line. So that's how much? 1/1000th of an inch. I go to 2. How much is that? 2/1000ths, 3, 4, 5. And of course, as I'm doing this on a real micrometer, it's going to be screwing out and getting further away from the 0. Right? That's where things are going to go tricky. So we'll start making it a little bit harder. So it comes around. What's the highest number this goes to?
40.
25.
You said 24. Yeah, it's technically correct. All right, so it goes to 20. So how much is this right here?
23,000.
Well, there's the 0.
24,000.
So that'd be 24.024 right there. Everybody follow?
Mm-hmm.
Okay. But I go just a little bit more, and that's 25.025. So that thimble is going to go tell me kind of that. And so if I go all the way around once, I have 0.025. All right? Now, when 0.25 shows up, I should have a little line right here. That little line right there, so that's, and every time it comes around, it's another 0.25. So we go from 0 to 0.025, 0.050, 0.075, and then 0.1. All right, let's back it up a little bit. So in a perfect world, when I come around to 0, I should see a little half a line like that, right? Everybody see that? Perfect world. Sometimes the world isn't perfect. Maybe I don't see that line. So how do I know that it's still 0.025? Got all that space there. That space had to come from somewhere, so that must mean that it went around one time, right? Okay, so it went around one time. Even if I don't see that little line, this means it has a bad personality. So maybe I see a little bit of a line, maybe I see a little bit more of a line. The point is, you have to be smarter than the micrometer and realize that it's gone around one time at 0.025. All right, so now what happens if I come over here like this, and it's looking like that? So what do I have? Now me, being me, this is one of the things that don't be afraid, I don't want to say cheat, but I'm going to say cheat. Don't be afraid to cheat in the right way. We're aircraft mechanics. We have to be right. We cannot make mistakes, correct?
Yeah.
So that means that don't be afraid to use a calculator, don't be afraid to use a piece of paper, don't be afraid to use whatever tools are at your disposal to get the right answer. So if it's too difficult for you to say, okay, it's 25 plus 7, and keep in math in your head, then don't. I don't. When I work on engines, I have a little scratch paper next to me all the time. I just write it down. 0.025, right? Because we got 0.25. 0.007, do the math. And then, if you have to use a calculator, I don't care. What is that right there? 5, 2, 1, you got 3.032. Okay, use a calculator if you want. It's fine with me. It's what they're there for, right? Units of experience. The more you use this, the more you can do the math in your head. But always be right. That's the number one issue. Be right. Okay, so we got 032. All right, so let me make something kind of hard for you here. See if you kind of paying attention. Okay, how much is that? Okay, always start. I'm going to do the math just like I did before, so I'm going to do it. So, what do I have here?
0, 25,
50.
All right, you want to go with that? I'm going to listen to you guys for a minute here. Okay, so I'm going to go 0.050, and then how many on here?
Negative
0.024. All right. So we got 47074.
No.
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 0.025 plus
if-
0.024.
if it
All
was
right,
at
remember what I
the
told you? You see how you're
0.5,
seeing that
then
little
you
zero
can
right there? You're seeing that line? You can't count that line because what is that?
This is
How much is that right there?
0.05.
How much is that?
0.05.
That's 0.050 right there. You guys added a whole 0.24 to this thing. Or 0.25 actually. See, the personality. Can't count that yet. Because what really happened is it's coming around up to that zero, and then you're going to count that, right?
Yes.
So, in order for us to have been right a minute ago with 050 plus that 24, it should have been all the way over here. And just about ready to hit the 75. See, because it was 074, which means it's just a thousandths away from 075. Question?
Yeah, you kind of lost me.
You
So
always-
like the lines have to match exactly?
No, what I'm telling you is the lines don't always match.
But I meant like the line this way on the wall has to match the sleeve line?
What I'm telling you is be very careful. Just because you see a line doesn't mean you can count it.
Okay.
You have to consider the space between. See, back here, I put it like that on 24. The real answer is 25 plus the 24. What, if I move it that much? Now it's 25 and 50. Yeah.
Okay.
Yep, it's got to be, just because you can see the line.
Doesn't mean that's 50.
Right, because if that were true, and that was 50 plus 24 for 74, then what is that?
51.
Well, the answer here is 51, but a minute ago you said 74. So how did it go from adding 2/1000ths of an inch going 74 to 51? See how wrong 74 was? It's very wrong. Always look at your space and think about it. Has it gone all the way around? Is it just ready to roll up to the zero? Or has it already gone around? Everybody follow me on that? Sorry, I'm blocking you guys over here. Okay, everybody follow? Because that's where if you can get that, you're like, you're most of the way there. Okay, let's try something else here. So we got to get on this side of things, and now we're going to do,
That 49.
let's do that. Now what do we got?
0.5.
Okay, let's
0.057.
we'll do it for the guys like me. A little bit slower. Okay, what's my first thing?
0.1.
0.1. Okay, 0.1. I can put all the zeros if I want. Doesn't mean anything. Now what? Now how many 0.25s do I have? Two of them. Okay, so I can do 0.25, 0.25, but I'm okay. I can do 0.050 on a piece of paper. So 050 is correct. Now how many thousandths do I have?
7.
Okay, you are correct. 0.007. So I have 0.157. Is that right?
Yeah.
Good job. Okay. So everybody's following me so far?
Yeah.
Take it up one more notch. Actually, if you can understand the whole concept of it, what I did before with the 24 and the line, that's really the hardest thing. Well, let's do, we'll bring it over here, and we're going to do that one right there. Now what do we have?
1.82. It's going to be a 40.
Okay, so what's my first number?
One.
Don't say one. 0.1.
And
Okay.
0.075.
0.75. Then what? 0.005. We're just going to work on this part right here. 0.005.
Yeah.
Okay, now can I just leave it at that?
No.
No.
Okay, we're aircraft mechanics. We don't leave it at that because it's not 0, 0. It's not ending in 5, right? Everybody can see that because this is 5. That is not 5.
Yeah.
All right, so should I round up or round down?
Round down.
Not
Down.
rounding anywhere, I'm an aircraft
The
mechanic.
Venire scale.
You want to work on, I can't think of something derogatory to work on. Do you want to be a portable toilet mechanic? Then I guess you can round, because they're made out of plastic and it's okay, right? But we're talking exact stuff here. So if this is all of the information that you have, then I say, this is me, I don't read it anywhere, then you make your best guess. And that's exactly the way I do it. And what is your best guess of that right there?
3.3.
Hey, Duncan says it's a little below half. What do you want to call it?
203.
You're just wrong. I'm just kidding. Is he? I don't know if he's right or wrong. It's his judgment. I can't, my judgment is standing right next to it. You said 3? He says 2. I'd say 3 to 4. And if you're doing this, and if Duncan would have wrote down 2, and I would look at that, I'd say, oh, it's his call. I'll go with it. All right. So you just have to make a judgment call, right? And about where you think it is. So we're gonna go with Duncan over there because he was the guy wearing the gold, the silver medal. And what did he say? He said 2.
Yeah.
Okay. So 0.0002. All right. So you make your best guess, and then we get all that up. Yeah.
So between the 5 and the 6, how many lines? Like what's the
10. There's 10 of them.
So
That's what the Venire scale is.
I haven't gotten there yet. So without it, you'd go, okay, well that's 0.0001, 0002, 003, 0004, 005, 006, 7, 8, 9.
Little 10 little lines.
Yeah, you pretend like
between
there's
that
10 little.
Okay.
Okay, but I don't always have to pretend because sometimes they're really there. Don't tell anybody I wrote that. They're really there. And that's what this is. This is called the Venire Scale. Now I haven't moved that other than drop it. So, right where Duncan said it was. So what I'm going to do is, I don't care what these numbers say. I need to care what these numbers say. All right? And what I'm going to do is look at which one of these lines lines up with something here. What lines up on there?
4.
The 4?
Yeah.
The 4. And you know what? This thing is surprisingly accurate. I don't know who made it, but my hand, props to them because this thing is pretty well done. So this 4 lines up with that. So that means that, sorry Duncan, you were wrong. It's 004. So if there's no veneer, you have to make your best guess. Give me your medal back. I think I licked that clean for you at lunchtime. It did. I actually used a napkin just to throw you out. All right. So if you have a veneer, you use the veneer. If you don't, you just do your best guess. Don't round up. Don't round down. Make your best guess. But if there's a veneer, you don't make your best guess. You do it. All right, all the way out. So in this case, it's 4. 4 10,000ths of an inch. Yes. 17. Yep, 10804.
That'd be 180.
Yep. So we did it all. Oops. 4 0. Carry the 1 8 1. So 0.1804. And that just takes practice. All right. In practicality, there's some things that you want to, that's slanting. You want to be careful of. So when you're making your measurements, on a crankshaft, I'm actually going to take a lot of measurements and really experiment with it. But what I'm asking you guys to do is rather simple. And that is you're going to measure a journal. So we have the main journals and the rod journals, and I've explained them in your worksheet what you're going to do. Now notice there's an oil hole right here. Don't measure the oil hole. Don't measure inside because you get the stuck in there. Don't measure next to the oil hole. Measure off of the oil hole. And I like to measure right in the center of that journal, up and down. So I'll do this one up here. So what I'm going to do, and I usually do it facing me, is I'll bring it in. And notice you use the clutch and kind of rock it up and down a little bit because I really could get it this. Can you everybody see how crooked that is?
Yeah.
I'll do that. Do you think that's a proper measurement? No, but yet listen. Is the clutch working? So I see people, this is exaggeration, but it's, you might as well do that. And then you go, okay, and you read it. Oh, that's really big. Yeah, I think it is. So you want to bring it on there, and I'm doing backwards for your benefit. So I normally be standing on that side. And I rock it up and down just a little bit until I can feel it's nice and flat in there. And nice and gentle. Okay, don't, you know, you see people just, I'm like, okay, I think you're done. A couple of clicks. What's that?
You can make it tighter by.
You really can, yeah. And that's the thing that bugs me when I go to the gas station. You hear people with their gas, they just keep doing it. I'm like, okay, once is enough. All right, lock it. There's a little lock on here. Some of them have a swivel lock, and some of them have a rotating lock, and some of them have locks that don't do anything. Okay, now when I take it off, I'm actually going to look at my thimble and the numbers. I'm going to watch it so it doesn't move, and I'm going to take it off very carefully and feel it. I'm evaluating the pull as I come off. It should be a nice little drag coming off, not rocking, not sloppy. And then carefully, I'm going to take it and I'm going to read my numbers on here. All right, and so I've taken one. Well, I don't normally do it this way. I take it one. Back to where the hole is. So you want to take two measurements. One here, and then one here. 90 degrees apart. And so I'm going to take two measurements. Every time I do this, I hate myself for doing it. Silence when I figure this out. There we go. Up is back, back is front, forward is back, autofocus. You see that? Okay. It's a little upside down, sorry, let's try it. It'll be right side up would be better way to go. Okay, so what do you can you guys see that? Or is it too low? So we've got 8.
Oh, there you go.
Except she's filming. I wonder how that's working out for the camera.
Actually, really good.
Okay. All right.
0.8.
Okay, so we got 8. Sorry, it's a little low. 8. We got. I can see 3 lines. Do I count that third line?
No.
No, because it hasn't even come to the 20 yet. It's starting to appear. So it's 0.8, 50, plus 15, 16, 17, 18.
19. It's 19.
So you can't see what I'm writing over here. Well, keyboard. Point. Putting that on Hannah. She's not here. Right. You serious?
I think your whiteboard's broken.
All right, wait. Yay! 0.8. I don't see it. 0.50.
Still can see it.
15, 16, 17, 18. 0.018.
The zero's lining up on
15, 16, 17, 18. This 19 hasn't hit yet. It's a little bit before the 19. So I'm going to go 0.0009. Now I could
Flip it around.
I could pull out my Venire on here and probably look at it, and I would see that, oh, the 9 does in fact line up on this. So it is 9. Hang on here. 5, 6, 7, 8. There's the 9.
Right on your
Straight
9.
on. It's mine.
Sure enough.
9.
It's almost like 9.5.
Well, it doesn't work that way, but that's the closest one. So yeah, it might be 9.5. So we got 9, so that's what we got on there. So let's see, let's add it all up. So we got 9, 8, 6. Okay, 0.8689. 1.86 because I'm using a 1 to 2 micrometer. Okay, so I did it in one plane. Now I got to do it in another plane. Right? So I put this on here. I do that. Bring it back over here. Let's hope it's different. Let's see. Too shiny. Can you see that? Okay. So we got, is it any different?
Yeah, it's a 10 smaller.
0.8, got 50, we got 18 again. Instead of 0.9, we're at what, point?
8.0.
Let's say it's 0.0007, so 7 ten-thousandths difference. Okay, so,
Is 7 10,000ths difference acceptable?
so we got the first time 1.8689, and the next time I got 1.8687. All right, are those the same numbers?
No.
Okay, so subtract them, I get a difference of 0.0002. All right, that is called the out of round. This number here is the out of round. OOR. That is the difference between the two. That means it's not perfectly round. All right, now, because this crankshaft is going to wear smaller, I'm most concerned with the worst number. What's the worst number?
7.
That is the smallest. So on my sheet, as a mechanic, really in the field, when I'm doing a crankshaft report, I'm going to put, that was the rear main, I put rear main equals 1.8687. That is my measurement I'm going with. And then I'm going to say out of round equals plus 0.0002. Now, I get hit by a bus, I forget who I am or something, and somebody's got to take over my job. Everybody in my shop knew they could come in and go, Kevin wrote 1.8687. That's the worst measurement he found on there. That's the smallest. And they're going to look at the book, the maintenance manual, and they're going to cross-check that and say, is this acceptable or not? Is it within new limits or is it serviceable limits? And they go, okay, so they're going to make their evaluation off of that because that's the worst. And then it also says in the manual, it has a max out of round. And they're going to look at it and go, well, the out of round is 0.0002. What's this plus mean?
So you're going up to.
Then it went up. In case anybody wants to know, it got bigger going that way. Because if I didn't write that, somebody could come along and go, well, it's 1.8678. So the out of round, did the out of round mean that it went 1.8675 or did it go to 9? But I put a plus there. So now you know what that means, right? What's that mean?
Going
up.
And it went up to 9. Follow? Everybody's going, I have no idea what he's talking about. Yeah.
Couldn't you write the 1.8689 and then below it minus and then 0.002?
I could, but I don't want to. Because when I look at the manual, let's say the manual said max service limit. I'm looking at the manual, it says the smallest this can be, the worst it could be is 1.8685. You need to know, did it meet it or not? Or I'll take that back. Let's say it was 1.8687. That's the worst it could be. But in my book, I wrote over here 9, and then I wrote 002. Now you gotta start doing the math. Okay. See, you want the worst number, because that's the number that you're trying to reference in the book. You don't want to write the best number, then have to subtract it again to come up with the worst number.
Excuse me.
Yeah.
For cylinder, you need to